All right, so let's talk about networking. The simplest thing you can do is port scanning, and we've already talked about this. You can connect to a server on a port and then print what comes back. So let me make this one here. I'm going to make my window smaller. There we go. All right, so if I probably split it in half, it should be all right. Okay, so if I nano grab.py, and I put in this stuff, this is, again, raw sockets. I create a socket object, I connect on port 22, and I just print whatever comes back, and that's all I do. Then I close the socket. So if I run that one, Python3 grab, it connects, and my server is running SSH, so it just gives you the SSH banner that's required by the protocol, and then it comes back. So that's fine. But now, if you go to a place that doesn't exist, like nowhere, then you're going to get an error. So if I make this the wrong thing, like wad.samsclass.info, a server that doesn't exist, now it crashes, and Python gives you a sort of ugly response telling you strange error codes and such. Some places a somewhat informative error, but it puts some stuff around it that tends to be confusing. So if you want to prevent that, then you use try. This is how you handle errors, and this is going to be important in port scanning because we're often going to try to connect to ports that won't connect, and we don't want the program to just crash and stop when that happens. We want to handle that error. So if you're going to do something that you think might fail, you do a try, then you start indenting the lines after it. So this is what you try, and if any of that fails, it will go to except. And you can then capture the error, if you like, from the module that had the error and put it in a variable as error and print it out. So let's see what this one does. All right, that one tries to connect, the server's not there, and so it just comes under my control and says node name, prints out just the error without that extra message. So that's good. Now another problem is timeout. So let me copy my original file, grab.py to grab4, and let's look at that one. All right, so here, if I connect to a server that does exist, and I connect on a port that's open, which is port 80, serving up the web page, let's see what this does. Python3 grab4. All right, it connects to the server. The problem is port 80 is not intended for humans to be sending code up and getting responses. It's intended for web browsers, and web browsers do not just connect and wait for response. There is no banner. Instead, it has to send a valid HTTP request. So it has made the connection, and it's getting no response from the server, and it's just waiting for timeout, which is going to be a really long time, like 2 minutes. So one way to fix that is to just add this set timeout to it, to tell it to give up more quickly instead of freezing up on me like that. I can set the object S, set timeout of 2 seconds, say. And now it will just not wait as long. And so now I didn't bother to do the proper error handling to make the error message pretty, but at least I controlled it. So then you can learn to accept user input, and in this case, you just use input, you put a prompt, and that will return a string. So then you have to convert it to an integer with the int command, with the int function here. So then you'll be able to connect to a server on that port. Now you can scan an arbitrary port, and so now you can find things. So there's a service defined here that ends in an even 1,000 with a banner. And then you can try finding another service here. There's 30 to try. So you have to make a loop and loop through them numerically, or you could even type in up to 30 times. And here's port forwarding. You're going to get a reply. It's going to include a port number. You're going to have to parse the reply, find the port number, and connect to that. This is a simple kind of port knocking. You only have 3 seconds to connect. So you don't have enough time to do it by hand. You have to write a code that will do 2 connections, one to harvest this string, and then make a second connection to that port. And here's another one. This one just gives you a whole paragraph of junk. and the port number is sort of hidden in there. So you're going to have to write some code that finds the port number by looking for something like this 222 and then noticing whether the rest of it is numerical, or you can use the sleazy thing I did and just find the first one and then only have a success rate of like 1 in 3 or 1 in 4 and just run it several times until you get lucky. All right, anyway, that's some simple port scanning challenges. And remember, I mentioned before, HTTP does not respond to a just a SYN-ACK connection. You have to send a request. So here's one that sends a valid request. So if I nano head.py and put this one in there, this one will just create a socket object and set the timeout. I put the target in a string so I don't have to type it all the time. And now here's a valid HTTP request. Head is the simplest HTTP method. You have to follow by the URL path, relative path to the object you're trying to reach, and slash is the root, and then the version of HTTP, which is almost always 1.1 these days. Then you have to have carriage return line feed and fill in the hosts and 2 carriage return line feeds, and this target has to match that URL. This will now be a valid HTTP request. Let's try that, head.py. All right, and so it sent a valid request. You know it worked when you get the status code 200. That means it understood your request and it was able to process it. And then you get the server's banner, which is not visible in a browser, but this is the start of every web page. It has a banner that tells you some general information like the server software that's being used and so on. It can also do things like set cookies. So now you can do a get login. If you open this, here's a page that you can log in. So if I put in A and B and log in, it's going to reject me. And you can see the A and the B just went right up here in the URL bar, U equals A and P equals B. Now, this is not a very common way to make a login, and it's not very secure, but it'll do for starting. So you can capture this at Wireshark. This is one of the many ways to get the code. But I'm going to show you another way, which is better, which is to use the console in your browser. So you should be able to find a developer console, developer tools, and down here you should be able to have a network console, and preserve log is good. So now if I go to here, I'm going to have to bring that up again, tools, developer tools. The exact clicks depend on which browser you're using. I'm using Brave, but it works in Chrome and Firefox too. Now, if I log in as A and B and log in, it's going to show me the network requests that made that. And the reason why the browser developer tools is better than using Wireshark is that this will show it to me even if it's an HTTPS page. But anyway, so here I've got the request and I can view source on the request here. And now I have the full get that got that page, and I should be able to copy it. Well, maybe I can't in Brave. It looks like I can. Highlight it and then copy. Let's see if that worked. Let's do nano get.py. And it did. All right, so this is the entire request that my browser sent. And now I can just put that in Python code. So if I go to here, so you can also get it from Wireshark. Although if you do, one thing you'll notice if you look at the response is it zipped, and that'll be a problem later. But anyway, here's what you want. So I want to put in all this code and put that in a variable called request. So I'm going to get out of here. That's my get. And then nano my head and just copy all this. All right. Go back into my get and paste that stuff in. All right. So this junk here should all be in request, REQ equals, and I can use triple quotes. Python supports multi-line strings. So that's pretty nice. It's not as nice as it used to be though. So that's the request. So after that request, I want to do this, move these lines, down here. All right. And now I don't need this line anymore at all. All right. So there's my first attempt to do this. Now, this used to work until about 2 years ago. The reason it stopped working is because modern versions of Python, if I just have a line feed right here in a Python multi-line string, that is just a carriage return, a line feed, but not a carriage return. And now the modern versions of Apache, which I'm using, require you to have the carriage return and the line feed after each line. So you have to add the return here to the end of every line, which is kind of a shame. But anyway, these raw sockets are pretty much on the way out anyway because everybody's using HTTPS. So, you know, it's not that big a deal. And in later projects, you use the requests library, which lets you easily make HTTPS requests. But if you want to do raw sockets, you'd have to add these \Rs all over the place. So if I've done that right, that will send that login request. Let's see if it works. All right, Python3, get. All right, and this is, believe it or not, success. It did make the request, it got the reply, but it wasn't able to, the response came back zipped, which you could see here. The response comes back as a zip file, and it can't understand it. So I can't process it as printable text here. So if I want to fix that, there's a simple cure. Down here, you have accept encoding gzip and deflate. That is the line that tells it that it's allowed to zip the response. If I just delete that line, it will send it back to me in plain text. There, now I get a reply that I can read with the typical Apache header, and then the page, and now it's telling me the login is rejected. So now I can send a valid request to the server and get a valid response. And the only problem is I keep getting rejected because I don't know the right password. And so then you can also do it with a post. A post request is very similar. The only difference is you have to put the username and password down here after a blank line, and you have to specify the content links, which is the total number of characters here. U equals A and P equals B is a total of 7. So it's quite similar. And so you can do a post login here to get the flag. And now you can start doing brute force, where you just have to fill in the username and the password, and you can brute force your way into here. And then you can try basic authentication too, where it uses this base64 encoding stuff for the username and password. Anyway, so there's a few challenges there to solve. All right. And then you can use the requests library, which is lets you use HTTPS and start logging in there, which is, of course, the way everybody's doing it these days. Only very old websites still log in without encryption. So I'm going to stop this one.